Okay, what you should have out on your desk at this time is your homework from 5.4, technically classwork because we do it together in class. We didn't get to finish it, and there were some at the end that I never had a chance to go over with you, and I'd like to do that now. So your assignment 5.4 should be on your desk, and first one I'm going to go over with you is number 42. Is parentheses secant theta minus tan theta times the quantity of cosecant theta plus 1.
Alex Casada, please come to the front office. Alex Casada, please come to the front office.
Equals cotangent theta. Okay, so obviously we're going to pick the left-hand side because it's bigger, it's more complicated. There's no way to take the right-hand side and try to make that into this. All right, and there's no squared, so there's no identity substitution I can do. I can change everything to sine and cosine, but I'd rather FOIL first and then change after. So secant times forgot my C. Cosecant. Secant times cosecant is secant theta cosecant theta. Nothing special happening there. Secant times 1 is plus secant theta. And then I'm here multiplying those two, nothing special there either. It's negative tan theta cosecant theta. And then here at the end, it's just minus tangent theta. All right, and as I stated earlier, I would then change everything to sine and cosine. 1 over cosine theta times 1 over sine theta plus 1 over cosine theta. Take away sine theta over cosine theta times cosecant is what? Correct, 1 over sine theta. Take away sine theta over cosine theta. Okay, nothing reduces here, so it's just one fraction of 1 over, I'm just going to write the sign first, sine theta cosine theta plus, nothing special happens there, 1 over cosine theta. Take away the signs reduce here, 1 over cosine theta minus sine theta over cosine theta. And I'm hoping you see that these middle terms, they're opposites. 1 over cosine minus 1 over cosine. They cross out. So it is getting a little bit smaller. 1 over sine theta cosine theta, not plus, it is minus sine theta over cosine theta. Now if you look here, I'm trying to get it to one term, looking at the other side, so I'm going to combine these by finding a common denominator, which means I'm going to multiply this second fraction by sine theta over sine theta so that the denominator can be the same. Sine theta over cosine theta, this stays 1, take away sine squared, and I'm hoping you recognize that's an identity. Cosine squared theta over sine theta cosine theta, and then recognizing that one set of cosines reduced, this one's gone completely, cosine squared becomes just cosine, leaving us with cosine over sine, and cosine over sine is indeed cotangent, equals cotangent, and there is your beautiful proof. Alrighty, next one I'm going to do is 65. Sine squared 35 degrees plus sine squared 55 degrees. And in the book it's asking us, it says use the cofunction identities to evaluate the expression without using a calculator. Okay, so we don't use calculators anyway unless we're using baby calculators, so that's not going to help us here. And recognizing this is not a Pythagorean identity. They're both sine squared. It should be a sine and a cosine. And these angles are not even the same. But it does tell us, it does say use its cofunction. Remember the complementary cofunctions. Pick one. It doesn't matter which one. I just picked the first one. You could pick the second one. It doesn't matter. Change it to its complementary cofunction. What's sine's cofunction? You put the co in front. It's cosine squared. What's 35's complement? You do 90 minus 35. And 90 minus 35 is 55. So you have cosine squared of 55 degrees plus sine squared of 55 degrees. And what is that? That one there is the identity. And it's not negative because when you flip on a positive sign, it's still the same thing. So the final answer is positive 1. And the last one I'm going to do with you is 67, which is cosine squared 20 degrees plus cosine squared 52 degrees. Now you can see right up here right away, 35 plus 55 is 90. Those are going to work. This does not add up to 90, but there is more. Plus cosine squared 38 degrees plus cosine squared 70 degrees. All right, pick one. It doesn't matter which one. I'm just going to pick the first one because I did the first one last time. Cosine squared of 20. Cosine's cofunction is sine because you take the co off. 20's complement, 90 minus 20 is 70. So I changed this. I'm going to cross it out because I know it's gone. I changed it to this, and I'm going to look for its pair, and here it is. Plus cosine squared of 70. Why do I want those together? Because that makes a Pythagorean identity. That one's gone. Pick another one. It doesn't matter which one. I'm just going to pick that one. Cosine's cosine's cofunction is sine. You take off the co, so you have sine of 52's complement. 90 minus 52 is indeed 38. So you have sine of 38 degrees plus cosine squared of 38 degrees. And I forgot my squared there. And now we have two Pythagorean identities. Sine squared 70 plus cosine squared 70 is 1, plus sine squared 38 plus cosine squared 38 is another 1, and 1 plus 1 is 2. All right, that is it for the homework problems I was going to go over. Your class assignment for today is worksheet 5, which the sub will be or has already handed out to you. And I have worked out the first few steps for each problem, and the worksheet's up on the whiteboard right next to the screen you are looking at right now. It's right underneath the date. You'll see a worksheet 5. It's with the magnet. It's there. It's not the whole thing worked out. It's just the first few steps of each problem. So you go up there only if you get stuck and you can't figure out how to do it. You go up there for some hints, and again, I didn't work it all out, just the first few steps. And that is it. Enjoy your guys' weekend.